Welcome to the last skill of Unit 2. Crazy. All right, we are solving quadratic inequalities algebraically, and it is really important to not just solve the inequality, but carefully analyze the situation that you're solving. Okay, that is the biggest advice I can give you on this one. What does that mean? Well, let's jump into it and find out. For this first one, we have it's in, yes, factored form. We have two factors that are set to be less than or equal to 0. The first thing that we want to do is find out what the solutions are, ignoring the inequality. Okay, we want to know, where do the x-intercepts lie for this particular quadratic function? So I'm going to take both of these factors and set them equal to 0 and solve. Sorry, yes, for right now, I'm ignoring the inequality. So we find out that x is equal to 4 and negative 7. Okay, here's where the analysis comes into play. If we have x-intercepts at negative 7 and 4, and it just so happens that this quadratic has an a value that's positive, this particular parabola would open up. Now, I'm not asking you to graph it, but just to kind of give us an idea of what we're doing. And we're solving for x values. So we're solving for the region on our x-axis, that when I pick those x values and I substitute them into the inequality, it will make this inequality true. Okay, so there's 3 different sections then. I need to find out if my solutions exist less than negative 7, between negative 7 and 4, or greater than 4. Well, let's see what kind of output these areas provide us. Okay, for section number 1, I need to pick a number that's less than negative 7. I'm going to choose negative 8, and I'm going to substitute it into the original inequality to see what kind of output values it gives us and if it makes it true. Well, that leaves us with negative 12 times negative 1. And it shows us that 12 is less than 0. So that's not actually making the inequality true. Therefore, as a reminder, I'm going to put a minus sign to the left of negative 7, showing me solutions don't exist here. Okay, the next region is region 2. And I need to pick a value between negative 7 and 4, and I'm going to choose 0. And I'm going to plug it in for every x to see what sort of number is generated. Is it less than 0? Well, I get negative 4 times a positive 7, which, this is less than 0. So I'm going to put a plus in that middle region to remind myself that solutions exist there. Now, there is one more region. Usually, if it's not on one outside of the parabola, if solutions don't exist there, it's not going to exist on the other outside area of the parabola. But I want to test just to make sure. So I'm going to choose 5 because 5 is greater than 4. It lies in the outside region I'm testing, and I'm going to substitute 5 in for each of the x values. And we end up with 1 times 12. Oops, I needed to mark that, sorry. And we end up with 12 being less than 0, which isn't true. So our solutions exist in between 7 and 4. But be careful, because this is where the inequality matters. It doesn't have an equal to. So it does not include negative 7, and it does not include 4. Instead, it includes all of the values in between negative 7 and 4. So we're going to say that x must be less than 4 and greater than negative 7. And those are the solutions for this particular inequality. Notice we didn't just say, oh, let's solve the quadratic and then set them less than, because it doesn't make sense. We have to think about what is being represented with this equation and where the solutions lie in relation to our x-axis in the parabola. All right, let's look at B. Well, yep, in order for me to solve, this is going to have to be equal to 0. So p squared minus 4p minus 5 is less than or equal to 0. All I did was move the 5 over to the other side by subtracting it. Okay, so now that it is in standard form, I'm going to factor it. You could solve a quadratic equation any way that you want, completing the square, quadratic formula, factoring if it allows itself to be factored. So I'm going to figure out what multiplies to -5 but adds to -4. For us, it should be p minus 5 times p plus 1 is less than or equal to 0. And just like we did with example A, I'm going to ignore the inequality at this point and just solve the two separate factors to find that our x-intercepts are at 5 and -1. So if I were to draw my x-axis, I know that the parabola is going to intersect at -1 and 5, and I know that I now have 3 regions for which to see if the solutions lie within either being less than -1, between -1 and 5, and or greater than 5. All right, here we go. I need to test. I'm going to pick a number that's less than -1, and I'm going to choose -2. You are more than welcome to substitute into the first equation, into standard form, or into the factor. Okay, they all come from the same place, and it's not going to matter which one you choose. Personally, I'm going to choose the factored form. Here we go. So I get p, oops, no I don't. I get -2, because I'm substituting in for p, minus 5 times -2 plus 1 is less than or equal to 0. Well, -7 times -1 is certainly not less than or equal to 0. So in that first section, I'm going to put that my solutions don't lie less than -1. For that middle piece, I'm going to choose 0 again. So I plug in 0 minus 5 times 0 plus 1 is less than or equal to 0. Maybe. So -5 times +1. Hey, this is fantastic. So we find that yes, -5 is less than or equal to 0. Solutions are going to lie between -1 and 5. Remember, this is where the parabola is intersecting the x-axis. Where do our solutions lie for x values to make this particular inequality true? We're testing the regions. So let's test for region 3. I'm going to take a number greater than 5, let's say 6, and substitute it in. 6 minus 5 times 6 plus 1. Is this going to generate a negative number so that we get a value less than or equal to 0? Sadly, no. No, it doesn't. So we can say that solutions do not lie greater than 5. All right, our final step after we've analyzed is we see that they exist between 1 and 5, our solutions do, and we look at the inequality. It is equal to, so I am including -1, I am including 5. I'm going to write that p is greater than or equal to -1 and less than or equal to 5. Nice. And I used p because that was the given variable. Be careful about that. All right, let's look at C. We have a couple more coming at us. Again, this is not in standard form, so I'm going to go ahead and subtract 4 to both sides. I get 6s squared plus 5s minus 4 is greater than 0. And in order to solve, we could factor. We could use completing the square. I'm going to go through the x method factoring, the x factor method, just in case we need some extra practice, okay? So locating A and C, I multiply them to the top. So 6 times -4 is -24, and B, in this case 5, drops to the bottom. So we need to figure out what's going to multiply to -24, but add to 5. And in this case, it's 8 and -3. Now, since these two numbers add to 5, I'm going to substitute them in for 5s. I get 6s squared plus 8s minus 3s minus 4 is greater than 0. And it doesn't matter what order you write 8 and -3 in, you'll get the same answer regardless. And then we need to factor by grouping. So factoring out the GCF from 6s squared and 8s, I get 2s, leaving behind 3s plus 4. And the only GCF for these last two terms is a -1, so I'll factor that out, leaving us with 3s plus 4 being greater than 0. All right, since these are the same, that's what we want. We're going to factor that binomial out, 3s plus 4, leaving behind the 2s minus 1 being greater than 0. Alrighty. Nice job, everybody. Hopefully you're with me still. Okay, I am going to now solve for S, ignoring the inequality, because again, we need to understand, we need to know, where does this particular quadratic intersect the x-axis? So for the left-hand side, we get S is negative 4/3. So negative 1 1/3 is one of our x-intercepts. And for the right-hand side, we get 1/2. Okay, these are the x-intercepts. We need to figure out, does or do the solutions for this quadratic inequality lie on the outside or on the inside of these x-intercepts? So let's go ahead and, pardon me, pick a number that's less than negative 4/3 and test it. Let's see if it is. I'm going to choose, oops, not in blue, I'm going to choose negative 2. And I'm going to substitute, remember, you could do the original, the standard form, the factored form. I'm going to choose the standard form. Okay, so 6, and I'm choosing negative 2, quantity squared, plus 5 times negative 2 minus 4. Is that greater than 0? Well, 6 times 4 minus 10 minus 4. Right now, I can see it's not going to be, because this is 24 minus 14. So I can go ahead and say it's not. Oh, whoops, I thought it was less than. Oh, yep, that's way to go, Patterson. Okay, so right away I can see that it is, I thought it was less than, greater than, because this is going to give us a positive result. So this is kind of nice. We haven't seen solutions on the outside of the x-intercepts, right? Okay, and then to pick a value that's in between negative 4/3 and 1/2, I again am going to choose 0. So 6 times 0 squared plus 5 times 0 minus 4. Is that greater than? No. Here's my no. So solutions do not lie in the middle. All right, last but not least, I need to pick a value that's greater than 1/2. Again, if you're comfortable with your arithmetic and you know that if solutions lie to the left of negative 4/3, they're going to lie to the right of 1/2 because of how the parabola is. Remember, the parabola for this one is going to open up, so we're trying to figure out where the solutions lie in relation to the x-intercepts. Okay, 6 times 1 squared plus 5 times 1 minus 4. Is this greater than 0? We have 6 plus 5 minus 4. And you can see right away that 11 minus 4 is going to be greater than 0. So we can say that the solutions do lie over here. Okay, inequality time. It does not have the equal to. So solutions will be less than negative 4/3 or greater than 1/2. This is really important. And versus or. If I am, let's go back to number 1. If my solutions lie between -7 and positive 4, right? Can you be a number that is greater than -7 and less than 4? Yes, you can. If I were to pick -2, well, that's greater than -7 and less than 4. But for this particular example, I cannot find a value for x, a solution that is less than negative 4/3 and greater than 1/2. It just doesn't make sense. So we say that x is less than negative 4/3 or x is greater than 1/2. Those solutions cannot coexist because there isn't a number that is less than negative 4/3 and greater than 1/2. Please be careful with that distinction, you guys. All right, here we go. Keep on moving. D. Ooh, this is all sorts of out of order. So what am I going to do? Put it into order. I'm going to write the quadratic first because this is standard form, plus the linear, and then I'm going to add 16 to the other side. I don't change the inequality because I didn't multiply or divide by a negative. I just added 16. And then I need to figure out, okay, what multiplies to 16 but adds to 8? Again, I'm choosing the factor. Ooh, and I see that it's D plus 4. You know what? Sorry. Pause. I totally used the wrong variable over here. I know, gosh. Like Patterson, I was just getting into that. It should be an S. My apologies, ladies and gentlemen. Okay, so back to factoring. It should be d plus 4 times d plus 4. 4 times 4 is 16, and then 4 plus 4 is 8. When we solve this, this is what we talked about with a double root. It's the same solution twice. So what does this mean? Yes, very good. This means that the quadratic has a vertex that is on the x-axis. So this is a little bit different. Here, I only have two regions to test. Because if I'm sitting on the x-axis, I'm either to the left of my vertex, right, to the left of that x value, to the right of that x value, and or including that x value. So let's test, and I'll show you what I mean. I'm going to first test region 1, and a number that's less than -4 is -5. Okay, I'm going to use the factored form. So -5 plus 4 times -5 plus 4, is that greater than or equal to 0? I'm going to say yes, because I can see right away I have a negative times a negative, which gives us a positive. Okay, so we do have solutions that lie to the left of the only x-intercept. Let's test to the right. A number that's greater than -4, yep, you knew it, 0. So 0 plus 4 times 0 plus 4, is that greater than or equal to 0? Well, yes, because that's 16. Excellent. So we know that, oh, Nelly, we know that that region to the right of that x-intercept is also going to work. We need to not forget about, pardon me, the actual x-intercept of -4, where the vertex is sitting. This is where the inequality really comes into play. Do we include it? Yes. Yes, we do. So we say that solutions exist to the left, they include -4, and they exist to the right. How do we write this? We write this as all real numbers. So we can say that x belongs to the set of all real numbers, or you can say that x is equal to all reals. Some form of that answer, okay? That's kind of neat. So crazy, right? When it sits on the x-axis, whew, so neat. Okay, here we go. We've got 2 more, ladies and gents. Ooh, this looks familiar. Okay, pardon me. Here we have it already in standard form, and I can see that right away. Oh, pause. I did it again, didn't I? Yeah, it's not x. You guys have to, if we were in class, I know you would call me on it. I know you would. It should be d. D belongs to, or D equals, golly. Maybe by the end of these video notes, I'll figure it out. Okay, so here we are, the variable is f. And I see that it is, yet again, another perfect square trinomial of f plus 6 times f plus 6 being less than 0. What does this mean? This means that we have a double root where f is equal to -6. So the vertex, the x-intercept, is -6, and it opens up, okay, just to give us the little sketch. And again, just like we saw with the previous one, we only have 2 regions to test. Okay, so a number that is less than -6 to see if our solutions lie to the left of -6 on the x-axis. I'm going to choose -7. Okay, so -7 plus 6, and again, yes, I'm using factored form. Ooh, is this less than 0? And I'm going to say no right away. How do I know? Because this quantity becomes a negative, as does the second quantity. 1 is not less than 0. So solutions do not lie to the left of my -6. Okay. The second region is to the right of -6, so let's choose 0. Why not? 0 plus 6 times 0 plus 6 is less than 0. Is it? No, no it is not, okay, which isn't surprising because we know that if solutions lie on one outer area of the parabola, or one on the outside region of the x-intercept, that they also lie on the outside of the other. But for this, we're on the x-axis. do we include -6? Because if we were to substitute in -6, we would get 0. This is where the inequality matters. It does not say less than or equal to. It says less than, so we cannot include this. Are there any solutions? Nope, there are no real solutions to this inequality, so we say no real solutions. If it had said equal to, then yes, we would have just said f equals -6, and that's it. So you're seeing a lot of different scenarios in these notes, and I love it. Make sure when you're doing your homework you have this nearby, just in case you come across one of these different scenarios, okay? Last but not least, ladies and gentlemen, 9v squared minus 6v plus 1, less than or equal to. Okay, well, again, this factors to 3v minus 1 times 3v minus 1. It is so nice when it is the same factor, right? So I have one double root, and that double root happens to be at 1/3. What does this mean? Again, this means that the only x-intercept is at 1/3. My a value is positive, so it opens up. I'm going to have solutions either to the left and to the right of my vertex that is lying on that x-intercept, and or including the actual x-intercept. Let's test. We need a number that's less than 1/3. As I've done so many times before already, I'm going to choose 0. So we get 3 times 0 minus 1 if I use factored form, and 3 times 0 minus 1. Is this less than or equal to 0? Well, we end up with -1 times -1, which is definitely not less than or equal to 0. So in that first region to the left, solutions do not lie there. Which come to follow suit, yes, they're probably not going to lie to be greater than either, but I'm going to test just like I've done before. So a number that's greater than 1/3 would be 1. We get 3 times 1 minus 1. I'm just using the factored form again. 3 times 1 minus 1, is that greater than, or sorry, less than or equal to 0? I can tell you right now, just by looking at it, that it's not less than or equal to 0, because we get 2 times 2, which leads us to have 4, which is not less than or equal to 0. So we were correct. I know some of us like to cut corners and maybe like to just not test that second area, but it's always nice to ensure that our arithmetic was right the first time. All right, going back to our inequality, it is equal to. So we do include the 1/3. If we were to substitute 1/3 in, we would get 0. So for this is just what I talked about before. On the previous example, we only have one solution. V is 1/3. Yeah. Okay, so remember, ladies and gentlemen, solve, ignore the inequality, solve for your x-intercepts. Analyze the solution. Where do the where do the solutions lie in relation to the x-intercepts? And then write your inequality appropriately.